Hello everyone, how are you guys doing today? I hope you guys are having an awesome start to your day. Today is Bring Your Teddy Bear to School Day, which is pretty awesome. I have not been able to grade your tests yet, okay, but I will get that done as soon as I can. And so we are going to move on. I got a few activities for you guys to do tomorrow and Friday, so we are going to go over some notes today. So I will post the guided notes for you guys. I did create some guided notes, so I will post those. If you would like to print them off, I will do that. Okay. So let me post what I got. Post my slide. Okay. We're gonna be talking about vectors. Vector, 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 vector. Okay. And here are my guided notes. Okay. So what is a vector? That's question number 1. All right. What is a vector? Right. A vector is a mathematical quantity with both a magnitude and a direction. So it has a magnitude and direction. What direction is it headed? All right. And what vectors have we discussed recently? Well, we discussed about displacement, velocity, and acceleration. All right. We discussed about those 3 things. Now, if you have to pause the video at any point, you can do so. Okay. That would be a great idea. All right. Now, drawing a vector. So a vector is always drawn with an arrow at the tip indicating the direction, and the length of the line determines the magnitude. Okay? So hopefully that's kind of a review. Now, on a protractor, you need a protractor for this chapter. If you don't have one, I would highly, highly recommend getting one. That will make life 100 times easier. Okay? The sooner the better. Okay? So on this, going to the right is 0, right? 90 degrees is straight up, 180 is to the left, 270 straight down. Hopefully you guys have seen that before. Now, we're also going to add in some directions. So we have east, we have north, we have east of north, and north of east. All right, over here we have north of west, west of north, right? So if here's north, I'm going to the west. And same thing in the south, okay? So we're going to practice drawing some of these, okay? I'm not going to do all of them. All right, like I said, if you want to pause the video at any time, you can do so. All right. Now, first one says 5 meters. I'm going to start in the bottom left. 5 meters at 30 degrees. So what I'm going to do is I'm going to line up my protractor with the hole going over and then making sure my 2 lines match up. All right. And draw a dot at my 30 degrees. There's my 30 degrees. Now it says 5 meters. I'm just going to do 5 centimeters. Okay. Make sure my 2 lines line up. And there's my line. Draw my arrow. So that has my magnitude and direction. Okay. Looks something like that. Next one, 170 degrees. Okay. So I'm going to start in the bottom right hand side this time. Line it up. Circle, circle. Line it up. 170 degrees. It's way over there. 8 centimeters. Okay. Should look something like that. Okay. 170 degrees. All right. 20 meters south. Whoa. Okay. That's going to go off your page. That's going to go off the page. But south is just straight down. Okay. I'm not going to do all of it. It's just straight down. Okay. 4 meters, 15 degrees north of west. Well, let me think about that real quick. Well, here's west. Here's north. And there's north. North of west. So 15 degrees north of west. Okay. So I'm going to be looking at west. So there's west. I got to go 15 degrees north of that. Okay. There's 15 degrees north of west. All right. And that's at 4 meters. Okay. So just a little line. And hopefully it looks something like that. Okay. And then the last two, I'm just going to zoom in here real quick. E should look something like that. F should look something like that. Okay. All right, express the right direction for each vector. All right, so this first one, well, that's pretty easy. It's 50 degrees, right? If that's 0, that's 50. Or we could say 50 degrees north of east, right? If here's east, it's going to be north of east, okay? Or 40 degrees northeast of north. All right, so north is straight up. So if we're going east of north, that's only 40 degrees. All right. Here, well, if up and down's 90, another 70, 90 plus 70, that's 160. So your answer can be 160 or the other two. All right. Try solving the other 4 real quick. Pause the video. Okay. So here are all your answers. Hopefully you guys are kind of understand that and how to express the direction. Okay. Next, we're going to graphically add vectors. Okay. So what this means is place the tail of the second vector to the tip of the first vector. So when you add A plus B, the tail of the second vector to the tip of the first vector. You can see that right there. Okay. Here we go. So we're going to add these. We're going to add these 3 together. Okay. Now, 10 meters north. Okay. Well, I'm going to start in the bottom left. 10 meters north. All right. That's just 10 centimeters up. I'm going to be going off the page a little bit. All right. There's my first vector. Check. 7 meters at 30 degrees. 7 meters at 30 degrees. All right, so I got to line it up again. There's my 30 degrees. 7 meters. Oh, hopefully I stay on the page. There's my 7 meters. All right, so I'm going to draw my dotted line. There we go. Okay. And then it says, let's see, 4 meters at 90 degrees. Okay, 4 meters at 90 degrees. So I'm going to go straight down. Okay, 1, 2, 3, 4, a little bit. So it should look something like that. Okay, so my end result, if I just took the shortcut, it looks something like that. That's my shortcut right there. Okay, and that distance I'm going to measure. I'm going to measure it real quick. Should be about 11.3. So I measured it. It's 11.3, and the angle it's at is about 56 degrees. Okay, measuring the angle of it, 56 degrees. See how close we were. That's pretty close. Okay. Now when subtracting vectors, this is a little different. When you're subtracting or something's a negative, instead of going forward, you're just going to flip the vector backwards. So if you look at this B, you're still placing it at the tail at the tip of A, but instead of going forwards like we did in addition up here, you're going to flip B and go backwards. Okay, you're going to flip it 180 degrees. All right, so we're going to do a subtraction problem. Okay. Now, on your example, okay, it has different numbers. Okay, as you can see, it has 10. I changed that to 1 so it will fit on the paper. So 1 meter north, I think I changed this to 5. Yep, I did, 5. Okay. So let's see. I'm going to start in my bottom corner here. 1 meter north. Okay, well I don't want to start in the bottom. I'm going to start in the middle. That's my start point. I have negative A. Ooh, so 1 meter north, instead of north, that's going to change south. 1 meter south. Okay, 1 meter south. Okay, did that. Plus a B, so okay, this is positive. 5 meters at 30 degrees. Okay, there's my 30 degrees. Got to line up my 2 lines. 5 meters. Okay, 5 meters. Now I have a minus a C. So instead of going south of east, I'm going to go north. All right, I'm going to go north. So I got to go up and down. So there's that. Line it up. There's 90 degrees. And I got to go 4 meters. Man, that wasn't that straight, but that's okay. So it should look something like that, okay? And my resulting vector, all right, looks something like that. It is a total of, measuring it real quick, it's about 7 centimeters. And the angle of it is about 52 degrees, okay? Hopefully adding and subtracting kind of made sense. All right, there's a few more example problems. If you would like to do them, you can, okay? This is your answers if you did do it, okay? Now, mathematically adding vectors, all right? These are the 5 steps, okay? And I'm going to simplify them on my paper over here. Separate your x's and y's. Number 2, add up the x's. 3, add up the y's. Okay? 4, use Pythagorean theorem to find the magnitude. Okay? Use Pythagorean theorem to find the magnitude. And then 5, use inverse tangent. Use whatever you have. I like to use inverse tangent to find theta. All right, we're finding theta. Okay? So we're going to add up one example here real fast. Okay? So 10 meters north. Okay, so I have to separate my x's and my y's. Well, if I'm going 10 meters north, that's straight up. So my y is positive 10. It's going straight up. Or my x doesn't move anywhere. Okay. Let's do 7 meters. Oh, this is going to be difficult. So 30 degrees, if that's my line, 30 degrees is going to look like that at 7 meters. All right, well, I got to find the opposite and adjacent. So the SOHCAHTOA. All right. So the cosine is the adjacent. Cosine of 30 is equal to adjacent over the hypotenuse. And then the sine of 30 is equal to the opposite over 7. All right. So let me grab my calculator real quick. Okay. Cosine of 30 times 7, I got 6.06. So the adjacent is 6.06. That is my x. My y, sine of 30 times 7, I got 3.5 going up. 3.5 going up. Okay? So I got my second x and y. All right, let's look at C. 4 meters at 90 degrees south of east. So I'm going south 4 meters. Now that's actually going to be a negative, okay? Since I'm going down 4, my y is going to be down 4. My x is still at 0, right? If I'm just going straight down. And now we combine all of them. 0 plus 6.06 plus 0. I move 6.06 in the x direction. And let's see, 10 plus 3.5 is 13.5. I got 9.5 in the y direction. Okay. Hopefully you guys kept up with that so far. Now, if I'm drawing it out, I went 6.06 in the x. I went 9.5 in the y. Okay. What I want you to do is find the hypotenuse, all right? So you got to do a squared plus b squared equals c squared, okay? So if you plug it in, a squared plus b squared, take the square root of that answer, I got 11.3. So I got 11.3 meters. Now, what's my angle going to be? Okay, to find my angle, I'm going to take the inverse tangent, right? That's step 5. Step 5, take the inverse tangent. So the tangent, the inverse, okay, of the opposite. So the opposite, if I'm trying to find theta, the opposite is 9.5 over 6.06. The inverse tangent, 9.5 over 6.06. I got a resulting angle of 57.5 degrees. I'd say that's pretty spot on. Okay. And that is as far as we got today. Okay. Hopefully you were able to keep up with that. We will be applying what we learned today in activity tomorrow. And I'm going to change it a little bit so you guys are able to do it at home. All right. If you have questions, let me know. All right. New topic, adding some vectors, but hopefully start to get it. All right. So if you do, let me know. If not, have a great day, and we will see you guys tomorrow.